All right, well, welcome back. We are in the 1.6 section. We're going to focus on the first part of that section on solving compound inequalities. So I've got a few notes on the board. I've scrambled home to see if I can get this up for you tonight. So hopefully you're checking it and spread the word. If nobody, or if you hear somebody that didn't get it, maybe share with them. And I'll try to send the notice out as well on Planet High School. So anyways, here we go. When we solve compound inequalities, we're talking about two different inequalities happening in the same sentence, in the same math sentence. So there's two types. We have the type that says and the type that says or. I've got two examples up here. So one says right here, it says x is less than 5 and x is greater than -1. So what we want to focus on with the word and, if you look up in our little cheat sheet box, it says it's the conjunction, it's the intersection, it's what's the same. So we're kind of looking at where they overlap. So if I say x is less than 5, you see it here in red, it's going less than 5. Notice I didn't bubble it in, it's not equal to it, it's an open circle. And then the other part is greater than -1. So at my -1 location, I have my blue, and it's coming towards me this way. So what I'm concerned most about is where they overlap. It has to be this and that. So both of them have to abide by the rule. So my answers would be anywhere between that circle and this circle. So it has to be the overlapping version of both inequalities. That's an example of a compound inequality with the word and. The word or is a little different. It can be this or that. It doesn't have to be both. So we look up here in the top, and it says x is less than -2 or x is greater than 2. So I have my -2 and my 2 spots marked, and in red I have the less than -2. So I'm going away from the -2, away from 0. So it can be that space, or it could be the space that is greater than 2. And I meant to put that in blue underline, but it's coming towards me. So you see a gap between. It's either this or that. Less specific, while the and is much more specific. It has to abide by both. Okay? Let's look at a couple of normal examples. And before I go, the or words that we need to understand are disjunction, where you have two separated pieces, union, or put them together. So we put this and that together, and it's this or that. All right? All right, so next, what I want to focus on is an and example. So the word and, what does it mean and how do we apply it? So up here I have two inequalities, and it says 2x plus 3 is greater than or equal to 2, and 5x is less than 10. So let's see how they kind of coincide. First thing you always have to do is solve the problem with the inequality sign. Very similar to our equations. So I subtract 3 from both sides. The left side, it goes away. I have 2x left in black is greater than or equal to 2 minus 3 is now -1. My last step in solving is divide by the 2. And so I divide the -1 by 2. So x is greater than or equal to -1/2. So that's going to be part of my answer. Let's see what the other part turns out to be. 5x is less than 10, so I take the 5 and I divide both sides by that 5. And 10 over 5 is 2, so I have x is less than 2. So I have my x is less than 2, and my x is greater than or equal to -1/2. So what I'll do is I'll go to my graph first. You may be required to graph these as well, so you need to make sure you understand how to do this. The 1/2, the -1/2, says that I must be greater than or equal to it. So I bubble it in. It should be enclosed with the shade. And it's going to go to the right, towards me. The x is less than 2 is just less than, so I'm going to leave it as an open circle, and it's going that direction. Now technically these arrows would keep going the opposite directions like I just mentioned, but where they overlap, remember and, this and that, is the answer. So I just have to show this portion of it. Another way to write a compound inequality for and statements is put your variable in the middle and always have your arrows going to the left. And the hint is that if negative 1/2 is involved with a 2, it's less than 2, so put it on the left. It's kind of like you're counting left to right. Negative 1/2, 0, 1, and there's my 2. So x can be anything between these two values, and in fact it can be equal to negative 1/2. We'll practice this in class. But the arrows go the same direction, and they're always pointing to the left, and your bigger number is on the right, your smaller number is on the left. So maybe you ought to practice that with a different problem on your worksheet that I'll give you in class, or on your book work. A couple of notes. Interval notation. Interval notation says that when you use parentheses, you're going to provide like an interval for a space of numbers. So parentheses mean that it's not equal to, and the brackets mean that it is equal to. So if we refer back to our example a minute ago, negative 1/2 is the left side of our interval, and it's equal to. So we put the hard bracket, and then we put a comma, and then we put the 2, and the 2 is a soft parentheses because it's not equal to, as you can see in our example. We'll practice interval notation as well in class. So interval notation kind of looks like an ordered pair when you graph, but it's not that. And we'll try to make sure we know the difference. The last note I'll say is that if your solutions do not overlap, and we may see this example, then there is no solution to that problem. Okay? And this is for AND problems only. If they don't overlap in an AND problem, it's no solution. All right, let's move on to the OR problems. So the OR problem, I want you to remember that it's this or that. It doesn't have to be both, and it may not be both. So number 2, I have x minus 1 is greater than 2, or x plus 3 is less than or equal to negative 1. Okay? So we'll solve each of these individually. So we add 1, we add 1. So x is greater than 2 plus 1 is 3 now. Or x plus 3 is greater than or less than or equal to negative 1, so we subtract 3. Negative 1 minus 3 is negative 4. So x is less than or equal to negative 4. Now what I did, I went ahead, since we just saw interval notation, I switched it over to it. So if I've got to be greater than 3, then that means I can be anything above 3. So 3 is my small number. But I don't have a ceiling for this interval. So I'm going to go all the way up to positive infinity. And we can't equal infinity, so therefore we're going to have that parentheses right there. In 3, you can't be equal to it either in this case. So that's how you would show that interval notation. Over here, x is less than or equal to negative 4. So my negative 4, I'm going to be less than that, so my 4 is going to be on the right side. And it's equal to, so I'll have the hard bracket, and it's going to go all the way down to negative infinity. It can go forever, but I cannot equal negative infinity. It's more of an idea, not necessarily a number. Okay? And here's my graph. So one number was 3, so I charted my 3, and one number was negative 4, so I charted my negative 4. My 3, I'm greater than 3. So I did not circle it in, an open circle, and I'm going to the right, greater than that. And my negative 4, I'm going to the left because it's less than negative 4, and it's bubbled in because it's equal to. All right, so there's interval notation, the solving, and my graph all in one problem for an OR problem. The last thing I'll say about OR problems is that just like on the AND situation, there is a special circumstance. If the OR types overlap, the solution is all real numbers. And we'll show that in class too. So if you take this piece and put it right here, and that piece put it right there, you would actually occupy every number out there, because it can be this or that. So if you have any questions, make sure you ask in class tomorrow. I'll make sure that we go over some of this more specifically, and we'll have an assignment on it. We'll work on it in class. So Anyways, I hope you have a good night. Spread the word. Let's make sure you watch a video before class time. And always remember, flip, don't flop.